Hi, I'm Mr. Layman. Let's do some science. Today we're talking about physics. Chances are, if you're here, you're interested in learning about physics. Well, I've got good news for you. I'm interested in teaching you all about physics. So let's do it. Physics is the study of the physical properties of matter. Physics can be broken down into two major things: energy and force. Not that kind of force. Well, a little bit. Seeing as how the force is used to move rocks and things around. Yeah, actually, kind of. Anyway, physics. Physics involves the physical changes to matter, either in energy or force. In this class, we're going to be looking at both and experimenting with both. Good news, we experience physics all the time. Let's look at some examples. Number one, energy. We're going to be looking at several different forms of energy in this class. Their causes, their results. Energy can be created all the time. Take your hands and rub them together like this. Press hard and keep going. What's happening? The energy of you rubbing your hands together made heat energy. We also might call this thermal energy. It caused matter to gain energy by the friction of your hands. After a while, your hands will cool off. We call this homeostasis. Homeostasis, a term describing things moving towards balance. With heat, this is why cold ice cream melts or a hot pizza cools when you leave them out on the countertop. But it's not like the ice cream is gonna boil, and it's not like the pizza's gonna freeze if you leave them on your countertop. Okay, unless your countertop for some reason is in a freezer. Then the ice cream will freeze and the pizza will freeze. But the homeostasis there is the room temperature. Except in that example, the room temperature is you live in a freezer. Most of us don't, so that's why room temperature is this balanced thing of sort of, it's kind of lukewarm. It's not too hot, it's not too cold. Your hands have probably experienced homeostasis from you rubbing them together and then them losing that heat energy. They have returned to a state of homeostasis. But it's not like your hands froze, unless you live in a freezer, but you probably don't. There are other forms of energy. Kinetic energy, like whatever cool example I decided to put over here. I don't know what it is yet of me recording this, but it's probably something pretty neat. Radiation is also a form of energy, as unbalanced electrons lose their extra electrons so they can return to homeostasis. Energy. Motion is the other main aspect of physics, and you experience motion all the time too. Let's say you're in a plane. You notice the plane speeding up during takeoff, and when you slow down, when it lands, it kind of lurches you forward. But when the plane's just cruising along, you can fall asleep, wake up, you don't even know you're moving, even though you're traveling at 500 miles an hour. The feeling of being pressed into your seat, a form of motion, a form of physics. Physics also makes this happen in a car. This effect is called inertia, and it's why cars have seatbelts. In fact, it's why cars have to have seatbelts. Oftentimes, energy and motion impact each other. Going back to this, the faster you rub your hands together, the more friction is created, and the more heat there's going to be. Give it a shot. Less heat when I do it slowly, more heat when it's fast. But if you put soap on your hands, like when you're washing them, you might notice that you've now reduced the friction because the soap's kind of slippery, and there's going to be less heat energy created because there's less friction. Physics. As scientists, we are going to want to be able to test our scientific results. The easiest and most effective way to do this is creating a hypothesis. A hypothesis is an if-then statement based on what we think will happen. Let's say we have a piece of paper and a book. I should probably go get those. Okay, I've got my one piece of paper and I've got my book. They're about the same size. The book, it's made of pieces of paper, and there's 200 pages in there. So we can say maybe the book is 200 times heavier than the paper. If I drop them from the same height at the same time, the book's going to hit the ground first and the paper's going to kind of drift through the air. There's some variables in the way. A variable is something in the experiment that we are changing, or that's being changed, even though we might not want it to be changed. I really want to have as few variables as possible. Ideally, one variable. That way I can test for one thing. And the wind hitting the paper and making the paper do this is kind of messing up my experiment because that's not going to happen to the book. Only the paper's getting impacted by that. But another variable is the weight. Like the paper and the book weigh different amounts. So now that I have two variables, there's too many variables. I do like the part where they're about the same size though. So that's a good thing. But I'm trying to reduce the number of variables to get some better science. Crumbling up the paper means that the air won't catch it as much and give it some friction. Then what's going to happen if I drop the paper and the book? Neither of them are going to catch the air. Write your hypothesis in an if-then setup for what you think will happen when I drop both of these from the same height. Which will hit the ground first? Good news! It doesn't matter if your hypothesis is right or wrong. You're just using what you think, the knowledge you have, and just trying to make a prediction. And then you're testing it and studying the results. Oh no, I was wrong or whatever. Okay, fine. So then what happened? Why were you wrong? Maybe test the experiment again. See if you get different results or the same result. Maybe look into what's happening a little deeper. That's science. Try it and see. Drop something light like a Lego piece or a pen cap or something like that, and then drop something heavy like, I don't know, a baseball or, I don't know, a big rock or something. What happens when you drop both of them at the same time? One of them's way heavier than the other one, right? But you dropped them at the same time from the same height. Which one hit the ground first? The heavy one? The light one? They hit the ground at the same time? You're going to tell me what happened next time we're in class. If you did the experiment and you wrote down the results, here's the same idea, but rather than removing the wind resistance by crumbling up the paper, what if we removed the wind resistance because we removed all the air? Here are some feathers and a bowling ball being dropped from the same height in a vacuum chamber. In this vacuum chamber, they have removed all of the air, so there's no air to hold up the paper. Or in this case, the feathers. Why does this happen? That's physics. That's what we're going to learn this year.